Here we are back on more familiar ground, aren't we? Quadratic equations. You already know a lot about these. And now that you understand what you can do with a negative under a square root, now we can do more with quadratic equations. So this will be like things you've known before, but better. Okay, so as we get started, let's see, what are we going to be doing in this lesson? Solving standard form quadratic equations that have leading coefficients other than 1. Yeah, those are the trickiest ones. And we'll be solving by completing the square. It's a technique I particularly like. I don't know about you, but I don't always remember exactly what that quadratic formula is. But I find I can always remember how to complete the square. I'm hoping it will be the same for you. We're going to warm up here with some work with I. Remember how we never leave I with any exponent other than 1? So 5 isn't acceptable to us. We're going to simplify that by looking at it as I to the 4th times I to the 1st power. This will work out, won't it? I to the 4th power, if you look at that little chart, I square times I square, -1 times -1, it's equal to 1. And and of course anything times 1 is just itself. Multiply these together. We're going to use first, then outside. Let's do that. We multiply the first together, we get 15. The outside together, we get, it's positive. That's right, 35I. And then we do the inside, which will be positive again. All these will be positive. There's no negative in the whole thing. 6I plus 14I squared. Oh, an I squared, that will bring in a -1 to us. So we're going to end up having 15. This will simplify to a -14. We add them together, we have a +1. Then we've got 35I and 6I. Add those together, we have dividing. Oh, let me pull that down. Excuse me, I don't know why that's getting in my way. Select. Okay, I got it. I didn't even know it. Here we go. I'm going to take a look at this division problem. This is just like we did previously. We're going to have to rationalize our denominator. These parentheses will help you remember that we're multiplying. I don't know about this little thing. Let's make this little dot. Okay, what do I need to multiply by? That's right, we're going to use conjugates. This was positive, so this one's going to be, this one's a sum, this one's going to be the difference. And the reason we like these, you don't have to worry about middle terms, so let's go for it. 6 times 6 is 36. I don't have to worry about middle terms, so my next step is to multiply those together. It's going to be a negative 64 I squared. Up here I do have to worry about middle terms. I'm going to have 18 a negative 24i a positive 30i and finally the last is going to be a negative 40i squared. Negative 40i squared is the same as a positive 40. That's because I squared, of course, is equal to a negative 1. A positive 40 and a positive 18 will give me a real component of 58. And my imaginary component in the numerator is going to be the sum of these two. Down here, what's going to happen here? It's going to be a plus 64. I add those together, I get 100. So that's a blast from the past. That was what we did in our previous lesson. Okay, we're going to go on now to quadratics and solving this equation. Oh, well, if you have, as we do, one quadratic and one linear and no constant, there's no number being added here, and it's equal to 0. Oh, that's good. Do you remember what I think we should always do when we see a quadratic? We should think of the 0 product property. Seem to have a little trouble with my T's. Okay. And in the case, all three of these, we already have the 0. These are all quadratics, and they're already set to 0. That's good. The thing we don't have with any of these, we don't have a product. What we've got are sums. So we have to convert that into a product. In the case of the first one, let's factor out the x. Then we'll have 2x plus 7 equal to 0. And with this, we now have a product. So we can say one of these factors is equal to 0, and so is the other. Now, the nice thing about this one we already can stop. We've got it. This one we need to go a little further, don't we? This will become 2x equals negative 7, because we'll subtract 7 from both sides, which will become x equals negative 7 divided by 2. So there are our two answers. We have an equation which is to the second power, we know we're going to have two answers. This one, here's a different situation. The first one had no constant term. This one has no linear term. X to the first power isn't here. So this one, we actually don't even need to use the zero product property. We could, but the simplest way to do this one is to just say 5x squared equals, we're going to add 7 to both sides, and that will give us x squared equals 7 divided by 5. Then, if we take the square root of both sides, remembering to do plus or minus, we get x equals plus or minus the square root of 7 divided by 5. How many solutions did we get? That's right, we got 2. And there isn't any way to simplify this any further. This is just like number 2. Why even bother with it? Okay. 2x squared equals -3. Oh, I see why we're going to bother with this one. It's going to get us into some interesting territory. We're going to divide both sides by 2, so we'll have x squared equals -3 divided by 2. Then we'll take the square root of both sides, remembering we got plus or minus here. So we're going to have x equals plus or minus the square root of -3 over 2. Now what have we learned? We do not leave a negative under the radical. And we're going to use what we learned from the last lesson here. This is the same as plus or minus the square root of -1 times the square root of a positive 3 over 2. So x is equal to plus or minus I, there it is, so in the old days, before you knew about I, you would have said there are no real solutions to this one, and you would have been correct. There are no real solutions to this one. However, there are solutions. If we include imaginary numbers, complex numbers, we will find solutions, and we will find 2 of them if we are dealing with a quadratic. Remember that? A fundamental theorem of algebra? Completing the square, one of the techniques I think is really useful. If this is a perfect square trinomial, and if our a is equal to 1, then we'll have just x squared, and our b is equal to 12, what would the value of c be? Well, how would we figure that? If I were looking to factor this, I know that the square root of x squared is going to be x. I also know that in a perfect square trinomial, this has been doubled. because the inside and the outside are always equal. So I know it looks like this. And what else do I know? It's positive, so this would be positive, positive. So what is C? C is 36. Let's think about what we just did. We looked at the middle term. We looked at the value of B, which was 12. We divide it in half. We got 6. And then what did we do? We squared it. Keep that in mind. That's going to be so useful for completing the square. We take the coefficient of the middle term, divide it in half, and then square it. Let's try this one where we have something other than 1 at the beginning. All right. So if it is a perfect square trinomial, we know that this must factor into 2x and 2x. What else do we know? Wow. I'm not sure we actually knew that, did we? But we could think about it this way. If I were to factor the 4 out, oops, the pen back. If I were to factor the 4 out of this, which would be a good idea, wouldn't it? Then what would I have right here? Well, you could think about it this way. 12 divided by 4, right? If I factor 4 out, it's the same as dividing this by 4. We know what that would be, right? That would be a 3. Still got x plus, and now right here for my c, that's what I want to figure out, what my c is. We know whatever we have for our middle term, we take half of it. Half of 12 divided by 4 is 6 divided by 4. And then what did we say we would do with that? We would square it. So we would end up with, if we square that, looks to me like that could be simplified a little bit. So that would simplify to 9 over 4. Now, if I multiply this back in again, that will be equal to 4x squared plus 12x plus 9. So C is equal to 9. Notice what we did, though. We had to factor out this 4. Whenever we're completing the square, we want to work with x squared having a coefficient of 1. So remember to factor out the leading coefficient. And please, that means you factor it out of everything. So here it is, just symbolically. And we're trying to figure out what this is. We factor out the coefficient of x squared, whatever that was. And then we divide the coefficient of our linear term by 2, and then we square it. So let's try this one here. We factor out the coefficient of x. So we've got 3x squared plus 12 divided by 3x plus something. So this 12 divided by 3, that's right here. Oh, no, that's right here. We have to divide that by 2. When we divide that by 2, we've got, think about it like this, which would be the same as 2. Why don't we work with 2? That'd be so much easier. And then we're going to square it. So this would be 4. Before I tell you what c is, I need to multiply everything by that 3 again. So I'll have 3x squared plus 12x plus 4 times 3, 12. My c was equal to 12. What must be added to this binomial to make it a perfect square trinomial? Okay, the steps we go through every time, we factor out the leading coefficient. What is the leading coefficient in this case? 1. Nice, we actually don't have to do anything. Divide b by 2, and b is the coefficient with the linear, so that's going to be 8 divided by 2. And whatever we get for a result, we square it. 4 squared equals 16. So what we have to add is 16 to make this a perfect square trinomial. X squared plus 8x plus 16. If I needed to factor a perfect square trinomial, it will always factor into a binomial squared. This would be x. This would be 4. You take the square root of this, the square root of this, and you take the sign from the middle. That's going to come in handy in a few minutes. Solve. Here we go. Finally, we get to do something with all of this information. X squared plus 10x equals, now what I want to do is put a perfect square trinomial in here, and 23 is not going to do it. So I'm going to get 23 out of the way for a moment. I'm just going to subtract 23 from both sides. You'll notice that I left space here. That's so I have a place to put in a number that will make this a perfect square trinomial. So let's look at our steps. We factor out the leading coefficient, which would be 1. That's good, makes it easy. We divide the coefficient on the linear term by 2, so that would be a 5. Then we square, oops, yep, divide 10 by 2, we get 10 divided by 2 or 5, and then we square 5. So what do I need to add to make this a perfect square trinomial? 25. And you're probably hollering at me now saying, wait, you can't do something to one side of the equation and not do it to the other. Okay, I hear you. Let's put that in. Now I can factor this, can't I? It factors into a binomial squared. I just take the square root of this, which is x, the square root of the last, which is 5, and use the sign from the middle. And that all equals a positive 2. How clever is this? Because now I can just take the square root of this side, the square root of this side, remembering to do the plus and minus. So I end up with x plus 5 equals plus or minus the square root of 2. Of course, I'm not interested in what x plus 5 is equal to. I'm interested in what x is equal to. So I'm going to subtract 5 from both sides. I've got x equals negative 5 plus or minus the square root of 2. So here I had a quadratic equation. I expect to have two solutions, and in fact I do. Because another way I could write this, I could say x equals negative 5 plus the square root of 2 so I have my two solutions right there. Okay, so let's try this now on something that's a little more complicated. Because this time the a is 9 rather than 1. So we are actually going to have to do that first step. So we're going to say 9. Oop, wait a second. I have another idea, something we should do first. This thing here, let's get it out of the way right up front. We know we're not going to be needing that, or at least I think we're not going to be needing that. So we'll subtract the 4 from both sides before I factor anything out. When I subtract 4 from a positive 2, I'll have a negative 2. Okay. Now let's do our factoring. So I've got 9 x squared minus x, and I'm going to want to make this into a perfect square trinomial equal to negative 2. Well, I have to figure out what that's going to be. My b in this case is 1. So I divide b by 2. Actually, it's a negative 1, isn't it? I divide b by 2 and then square it. Divide by 2 and square. When a negative is multiplied by a negative, I get a positive. When you complete the square, this c term, I'm trying to get down here, it's always going to be positive. So that'll be a plus 1/4 plus 1/4. Oh, what did I just do? I added 1/4 to one side, and that 1/4 is multiplied by 9. So in fact, I just added 9/4 to this side. So this equation is out of balance until I add 9/4 to this side as well. Please notice that. Added 1/4, but it's being multiplied by 9. So I added a lot more than 1/4, and I need to add the same amount to that side. Okay, so we've got 9, and this will factor into a binomial, and that binomial will be the square root of x, the square root of 1/4, which is 1/2, and the sign from the middle. That is equal to a, oh, shouldn't I think about this as all fourths? That would make it a little easier. Let's see. Negative 2, if I want to put this all over a common denominator, I need to multiply this by 4 over 4. That's just a fancy 1, won't change its value. So I'll have a negative 8 plus 9, and they're both over 4. Now I'm going to take the square root of both sides, square root of this side, the square root of this side, only this will be plus or minus. Now when I take the square root, I've got to do 9. Square root of 9 is 3. Then the square root of a binomial squared, these are opposite operations, they cancel each other out, so I'll have x minus 1/2. And over here, I've got plus or minus the square root of 1 over 4. Ooh, that should be written as plus or minus 1/2, because the square root of 1/4 is 1/2. Now I'm going to divide both sides by 3. So I have x minus 1/2, and this will be times 3. So x is going to equal 1/2. I'm going to add 1/2 to both sides, plus or minus 1/6. You see how that happened. Let me pull this down a little bit. X equals, I need them both to have the same denominator, don't I? So this will be 3/6 plus or minus 1/6. Ew, okay, so when this is positive, when I'm adding 1, I'll have 4/6 or 2/3. And when I'm subtracting 1, I'll have 2/6 or 1/3. So there are my two answers, which I expected to have in any quadratic. And we are done. See you back in class.